Collaboration is the idea that objects work together to complete a task. Each object has responsibilities and plays a role in the system, and this necessitates that each object gets along well with others. The way they collaborate is typically through the sending of messages back and forth. Now, I recently read that the man who actually coined the phrase object-oriented programming regrets that name because of the focus that it takes off of collaboration. I mean, we often talk in terms of classes and properties and so on, and these are mere data structures. But what makes object-oriented programming interesting and useful is messaging, collaboration, conversations between objects to complete a task. So we often don't think much about communication and collaboration between humans. Maybe we should be thinking about that more often. But it happens easily and organically because we have a large vocabulary and we have an ability to reason through unknowns or ask clarifying questions on an ad hoc basis. A machine has no such intelligence to do this. All it knows is that it expects input in one form and creates output potentially in a different form. If it doesn't get exactly what it needs within a very narrow set of parameters, it throws its hands up in the air and says, I have no idea what you want me to do. It'll fail. So while we often don't think about it in very strict terms, even humans have communication contracts when we have work to do. We divvy up the work between all the members of the team. We understand that there are dependencies. I can't start on this before you finish that. We agree on what constitutes the completion of one task, and then we notify others whenever we've completed our task, because again, that might trigger other subsequent tasks that are dependent on it. And so then they take our work and they make sure that they can actually use it, that it makes sense, that it was done to completion, make sure that it's in the right format, it's that all the expected details have been addressed, and so on. And when that doesn't happen, there's usually some form of communication that goes on. We might even call that, in programming parlance, an exception happens. We expected this. It didn't happen the way we thought it would. So we need to raise the red flag and say, hey, you need to finish or redo it the way that we agreed to, right? And that happens again in a very organic way between two humans, two or more humans. But objects, they really have some similarities there. But again, their communication and their reasoning skills are pretty limited. So much of this negotiation has to be decided up front in the form of a contract. Now, in object-oriented programming, you can think of a contract in one of several ways. I'm just going to talk about two ways for now, and we might add on some other ideas, attach them to the idea of contracts later on. But the first and the easiest way to talk about contract when we're thinking about objects and classes and properties is to think about a method signature. So if you want me to do that task, that method, okay, then I'm going to need this information from you, and you can expect back from me this information, right? So I'm going to expect these input parameters, and then when it's all said and done, I'm going to return back to you a variable or an object of this type. Now, if I can't figure it out, I'll let you know. I'll raise an exception. So that's the one way in which objects can communicate to each other. A contract is through a method signature, but there's also the notion of an interface in C# and in other programming languages. And this is a special programmatic construct that defines a set of properties and methods and events and so on that a class must implement in order to take on a given task. So honestly, if you think about the method signature and an interface, over time you'll begin to realize that they're two sides of the same coin. But for now, I just want to keep things really simple. I'm working on the assumption that you've written enough methods already up to this point to understand everything you need to understand about how a method signature plays a part in a contract. I mean, again, the contract terms are you pass me in this and I'll pass you out that, okay? And if I have any problems, I'll throw an exception. Here's what I can do if you need me to do it, that's great. Just here's what I'm going to need from you to get started. However, I don't think up to this point, if you're following the curriculum religiously, I don't think we talked about interfaces, at least not much. So if you look at an interface, and I have an example for you here from Microsoft's own documentation. It's not a complete one, but it'll suffice for now. If you look at an interface, it might seem a bit strange because there's really not that much code to it. In this case, there's only one thing that's defined, a bool equals t of type object. However, interfaces play a really important role. And I don't want to spend much time about talking specifically about interfaces because we're going to devote entire lessons to them a little bit later on, but I just want to talk about this at a high level. Notice, first of all, the name that was attributed to this interface. It starts with the letter I by convention, and that's not required, but it's just a way to denote to other programmers that I intend for this to be used as an interface. Also, by convention, you'll notice that it uses the suffix able. And so it denotes the high-level activity that this contract is defining. It's defining an activity, in this case, of equation, I guess, of determining whether two items are equal. Okay, so is this equatable? I-equatable. You want to make sure these two objects are the same? That's fine. You're going to need to make sure that one of those classes implements this interface called I-equatable. So third, just like in real life, there's two sides to a contract, and then there's the contract itself. So on the one side, you have an object that knows how to work with an object that implements I-equatable, and on the other side, you have the object that actually does the implementing. It actually implements I-equatable. Now, if we take a look down in this little example, they only give us one of these. This car class, it actually implements I-equatable. It's of type car, but let's just focus on this. And notice that in order to implement this interface, this contract of I-equatable, it is implementing a method called equals, right? And so we can see that we're implementing the contract called I-equatable because we're also implementing a method called equals. There's no method body here. There's no implementation. All we're saying is that there has to be an implementation of this equals method. It has to return a Boolean and it has to accept the type of t, whatever the t is of this given object, right? In order for this to be a class that implements I-equatable. All right, so there's an old famous poem that turned into an idiom at some point. It says, "No man is an island." And we understand that to mean that we must work together with our fellow man and community. So when you think of objects, you should be thinking in those terms as well. Each object has responsibilities in its conceptual society, and it has to collaborate with other objects in order to perform work. In order to collaborate, there has to be some sort of contract up front. In the conceptual world, this takes the form of signatures, method signatures. It also takes the form of interfaces. So in this case, just to kind of clarify one last time here, we've defined the contract. We've implemented the contract. Unfortunately, what's not demonstrated here is the actual calling of the method equals to compare two instances of a given car to make sure that they're the same ones. And we're not really worried about how it's implemented. Just the fact that if we need this functionality, then we have to make sure that we're relying on this interface. And then the consumer and the implementer of that interface can work together, can collaborate, can exchange messages. All right. So let's continue on in the next video. We'll see you there. Thanks.